Hello everyone. Today let us discuss class template. Let's see what does it really mean. So what is a template? A template is a tool in C++ which accepts the different data types as parameters so that we don't need to write the same code for different data types. So, what is a template? It is a tool provided by C++ wherein it is capable of accepting different data types. See, I'm not talking about data only, I'm talking about different data types. It could be integer, it could be float, it could be double, it could be long double, anything. So, any type of data it accepts, then it does a calculation and sends the resultant to the main function as desired. Okay, I will take a small example of a normal object oriented programming. See, example is shown over here, wherein I'm calling a class called complex. Here, I'm very specific about the data member. Here there are two data members. What are the two data members? They are real and imaginary of type integer. See, very specifically it is mentioned there are two data which are of integer type, and associated to those data members there are some functions which has a specific return value if there are. So when it comes to add and subtract, it takes the complex data and it takes complex data. It may return a complex data. It's a very specific one, wherein this entire class is a for a specific type of data. It could be a complex number. Any object which is created of this particular class can be taken as an argument over here in these two examples, add function as well as subtract function, very specific. But template is not so. Template will accept the different data types. Normally, let me take an example of sorting. See, what do you mean by sorting? Arranging the numbers either in ascending order or in descending order. So now, why do we need template for sorting? Say for example, I'm sorting integers or I may sort real numbers. See, algorithm remain the same. Either you are sorting integer or you are sorting float. Algorithm remains the same. Program remains the same. But the type of data which you are passing to a function from the main will be different. So under such condition, it is better use the template which will accept either integer and it will sort the numbers and give the data back, or float, it will calculate and then gives the resultant back. So in general, of any different data types can be considered as parameters so that we need not rewrite the same code for the different data types. So, very important point to note here is the same algorithm for different data types work here. So, it need not be repeated. In the general case, in the general object oriented programming concept, separate objects, separate classes have to be written, but here it is not so. A general algorithm needs to be written, and the template will take either a real or an integer. So depending upon the nature of the data type, it will pick up and does the calculation. So one very important tool is this, which is used in the C++. See here, as it is mentioned here, I'm using a complex number. See, this is an example for uh, regular object oriented programming. So here I'm using real and imaginary as float. Then I'm calling the data, get data, put data, and then see, in this case, I'll just give the difference between two examples. Here I am declaring a class called complex, wherein I am calling two data members of integer associated functions. But suppose if I want of real type, once again I may have to rewrite the class with the float real and imaginary. Here it is integer real and imaginary. Here it is float real and imaginary. So here separate classes to be written, separate associated functions have to be written, and separate calculation needs to be done. But the algorithm remain the same. Here, addition or subtraction algorithm will never change. It will remain the same. But due to the different data types inside the object or inside the class, we may have to redefine the classes with the different data types. This is in the normal object oriented programming concept. So now let's see what are the different types of templates. Here we have two different types of templates. One is called function template and another one is called class template. So what is a function template? Here we can define a template for a function so that we can pass the arguments of different data types to that particular function, because the function is of general form. We are just defining a template for a function. We are not defining what is the arguments, what is the nature of the argument it is going to accept, what is the written value of the function. Here simply we are writing a template. The main program, when it is supplying the arguments, will decide the template to be either integer or float or something else. So here we are defining a template only, function template. We are not defining a function. It's a function template which is capable of accepting any data type. Okay, so suppose if we declare a function called add, so we can create the versions of add function for adding integer numbers, for adding float numbers, for adding double type values. Same template which can accept integer values and add them, which can accept float value and add them, which can accept double value and add them. So that's a function template. Similarly, we have one more called class template. So in case of class template, we are defining a class template. We are not defining a class of, say, having data members integer, having data members float, or having a specific data members. See, in general object oriented programming, it's very clear. We know that it may contain the group of different data members, but every member is specific with the particular data type. I may have 10 different data elements, 10 different data members, wherein one can be integer, another can be a float, another can be a character, another can be a string. So, like this, but they're all specific. But here, in case of class template, we are not mentioning anything. Data member, we are not mentioning. Either it is of integer, either it is of float. So, we are not mentioning. We are just giving a template of a class. Now, let's give an example for a function template. Just look at here. Here I'm using template class T T add T and A comma T and B. See here it is written. I am not mentioning what is the nature of A. See these are the arguments which are supplied from the main program. So here I am not mentioning A is an integer. Here I am not mentioning B is a float. Here I am not mentioning A is a float or B is an integer or A is integer, B is integer, A is float, B is float. I am not mentioning. I am just giving the template of it. So here result also is a template. So result is also a template which is adding the two numbers A and B. So it will return the result back to the main program. So here how a main program makes use of the template, let us see. See here I am defining four different variables I and j which are integers, m and n which are float. I and j which are integers, m and n which are float. Now here I am calling the function add I comma j. Just look at here. What is the type of I? Integer. What is the type of j? Integer. So now whenever I call this function, this template accepts integer. A will be integer, B will be integer. They are added. Resultant also becomes an integer. So that will be displayed here. For this instance, for this particular line, the function becomes integer. It's a template actually. It's a template. T add T and A, comma T and B. It's a template. So which will add two integers. When it comes to integers, I and j are integers. So these integers are passed over here. The entire function becomes an the arguments to this function become integer values, and after adding the resultant also become an integer for this particular example. Let me go to next example wherein I'm adding m comma n. What is m? It's a floating point. It's a real number. Then what is m? It's once again a real number. But did I make any change in my function? I didn't make any change in my function. But the data type which I'm passing from the main program to the function subprogram remain, or it keeps on changing. The function subprogram remain unchanged. So it is not changing because it's a template. So when it is called with the integer value, it will accept integer value. Now in this case, m is 2.3, n is 1.2. Now a becomes 2.3, b becomes 1.2. So 2.3 plus 1.2 will be added. So 3.5 will be the resultant which goes out of this particular function. So arguments become real, the return value also becomes real for this particular example. But for this particular example, arguments are integer 2 and 3. 2 plus 3 becomes 5. So that will be returning to the main program here. So now the return value becomes an integer. For this example, the return value becomes a floating point or a real number. So there is no change you can see in this function because it is a function template. So it is a function template. So I think it's very clear by now looking into this example. Now, similarly, we have a class template. So here I am mentioning template class X and class Y. Here I am just mentioning the templates. X and Y are the classes of template. I'm not mentioning any particular data elements here. So here A is of class X, B is of class Y. So A is an object of class X, B is an object of class Y. So what are they? They are the class templates. They are not the regular basic classes. They're the class templates. So anyway, the details are shown over here. So wherein you will be supplying the values 15 and 12.3. So see here, I'm supplying 15, I'm supplying 12.3 because here it takes an integer value, but this takes a real value because they are objects of the class X and class Y, which are class templates. Now, let me go to the problem. Let me go to the program. So, the problem statement is so. Write a C++ program to add, subtract, multiply, and divide the two numbers using class template. Okay. So now here we are supposed to define a class template for addition, subtraction, multiplication, as well as division. So, in this program, addition, subtraction, multiplication, and division are done with different data types. But a single general class is defined for all these data types. You need not separately define a class for integer, class for float, class for others. One gen- general class is defined, and that is a template which will accept different data types. Let's analyze the problem. So what you are supposed to do is you have to define a class called calculator with the two members. See, it's written add, subtract, multiply, and divide two numbers. So a class has to be defined with the two numbers. What are the two numbers? Number one and number two. But it is a class template. So I am not mentioning, or we are not mentioning num1 and num2 are of what data type. They are not of a specific data type, but they are of the type template, which can accept any type of value at any moment while calling the function. Then step 2, a public function is defined inside the class to accept any value of any data type from the main function to the class members, namely num1 and num2. So now I'm doing the same thing. Here I'm calling a class called calculator. Step 1, define a class called calculators. I have defined a class called calculator with the two members, namely num1 and num2. So here there are two names called num1 and num2 of what type? Template T. So here num1 and num2 are of type template. So make it very clear. I am defining a class called calculator wherein there are two data elements in the private section of type template. How it changes its value, let me explain you later. Now I'm calling a function wherein I call a calculator wherein n1 is an argument which I'm taking from main program of template, n2 once again a template. So n1 and n2 are the arguments which are accepted from the main program. That's why they are mentioned in template T T. If you supply an integer, n1 and n2 becomes integer. If you supply a float, n1 and n2 becomes float. So like this, that's why I am declaring them as templates. Here, The private members num1 and num2 are also template. Here the arguments which you are taking also are template. So now you take the data from the main program, move it to num1 and num2. So this is your calculators class. Of course, it is not complete, wherein you display the result. What are you displaying? Num1 and num2. So addition, you call a function called add, which I will explain you now. For subtraction, you call a function called subtract, and multiply to get the product, divide to get the division. So there are four functions: add, subtract, multiply, and divide. These are the four functions which are the part of your class itself. It should be defined inside the class itself. So let me repeat once again. I am declaring a class called calculator with the two data elements num1 and num2, which are templates, and calling a function under public called a calculator with the n1 and n2 two arguments. Once again, they are also of type template. So I'm moving the value to num1, moving the value to num2, and this values I'm displaying here. I'm calling a function called add. To add the two numbers, I'm calling a function called subtract. To subtract the two numbers, I'm calling a function called multiply. To multiply the two numbers, and I'm calling a function called divide to divide the two numbers. So now, what are the functions? See, there are four functions I called, right? Add, subtract, multiply, divide. What are the functions? Add function will add the num1 and num2. Once again, it is a template. Subtract is a function which will subtract num2 from num1. Once again, it is a template. Multiply will multiply the two numbers num1 and num2. Once again, it is a template. Divide, divide that num1 with the num2. Once again, it is a template. Return is a template. So here my class ends. So my class starts from here, declares the two members, moves the value into the data elements, the private data elements. This is used to display the content, and these are the functions which are used to add, subtract, multiply, and divide the numbers as templates. Now let me come to main program. See here, this is a very important point wherein we need to look into. I'm using a calculator. It's a class calculator of type integer. Right now I'm using integer with the, see what is int calc? Int calc is an object of type calculator and integer type. So now template becomes integer here. So the moment I supply 2 and 1, what will happen? See, int calc dot display results. Okay, int calc dot display result. What is int calc? Int calc is an object of integer. See, in my everywhere I mention template only. Now here by mentioning integer, I am giving a meaning to template. So everywhere my t will be replaced by integer. So let me go accordingly. So now I will take this example, calculator integer int calc 2, 1. So when I run this function, int calc dot display result. So what are the arguments which are getting supplied? 2 and 1. Now this function will execute. This function will execute. So already I mentioned n1. What is n1? 2. Okay, n2 once again 1. So n1 is 2, and 2 is 1. So template here is replaced by integer because it is of type integer. So now 2 will be loaded to num1, 1 will be loaded to num2. So here numbers are 2 and 1. Now afterwards, because I am running this function int calc dot display result. So display result, int calc dot display result. Return is int calc dot display result. Int calc is a object. So now I'm adding, what are I'm adding? I'm adding num1 2 plus num2 1. So return is once again integer because here I have declared it as an integer. So subtract, next is subtract. So this is a function which is getting used here. So it is called, actually this function is called. This is executing, out of which add. It's going to add the numbers. So 2 and 1. Second one, subtract. Another function, 2 minus 1 of integer type. Return is also integer type. So once again, next is multiply. So num1, 2 into 1, return is an integer. So next is divide. So 2 by 1. So return is an integer. So now here this function will call this function, and while executing this function 1, 2, 3, 4, these functions are called with the arguments 2 and 1 because in the main program the type is integer, then it supplies 2 and 1. Similarly, I am defining one more object called float calc of type calculator, but here template is now replaced by float. This is a float and arguments become 2.4 and 1.2. In the previous case, int calc is an object of calculator integer type with arguments 2 and 1. Now float calc is once again an object of calculator with the float, and the arguments are floating point arguments. So once again here also I can have same calculation, but here float calc dot display result. Here everywhere this becomes float, argument becomes 2.4 and 1.2, they get displayed and once again they get added up. So now this is how your template works. See, please make a note, in the class template nowhere data type is mentioned, but because of the main program here, this gives a meaning to the class. It is of integer. Now when it comes to here, this gives a meaning to the class. It is a float. So that's why we have seen the class template. So the same class can have a different meaning. It can accept different data types and perform the calculation based on the nature of the echoing or calling object from the main program. So this is the concept of the template. Okay. Thank you.